replicated since then. This was done with children in first grade. And let me give you a set of data and show you what that looks like. Actually, can you do that for me, Kenzie? Thanks. So what Kenzie's handing out is this sheet right here. And Rosenthal and Jacobson were the researchers. And here's what they did. They had a theory that this kind of goes back to this idea of digging in the files I was just telling you about a few minutes ago. Their theory was that if you believe a student is going to do well in your class, they're more likely to do well than the students who you don't think are going to do so well. And so what they did is they kind of got this whole, how does your attitude and belief about particular students influence how those kids will perform in your classes. So here's what they did. They did, this study was looking at intellectual gains. The students were, let's see. So these were first grade students. And they took this group of kids and they gave them a pre-test at the beginning of the year. Okay, first graders coming in the beginning of the year, what do you know? What's your baseline knowledge level? And they measured that. They gave them a score. And then they pulled these teachers aside and said, oh, by the way, you ought to know that Anne is a really good student and she's likely to see a huge gain in her score this year. Just know that. On the other hand, Katie has struggled a little bit in the past, and I'm not sure she's necessarily going to see that kind of a gain, but I can tell you that Anne will. And they did that. And what they did is they took an experimental group and they told them, these are the students that we suspect this year are going to really, you're going to really see some big gains in based on what they did in kindergarten. Just be aware of that. Okay? And then they went through 8 months of the school year and through the normal teaching routine. And after 8 months, they gave a post-test to all of those kids. And what they wanted to know was, what was the gain? How much did the kids actually increase in their scores? And can we make a claim that the group of kids who the teachers thought were going to do better actually, in fact, did better? Even though they were randomly chosen, by the way, because we don't even know whether Anne's going to do better than anybody else, but I just told you that Anne was going to do better. Okay? So what you've got on that handout, these are the gains. This is an actual set of data from 20 first graders in that study. And the experimental group here, these are the gains. So for example, the first student here gained 35 points from the pre-test to the post-test over the 8 years, and so forth. These are the comparisons. These are the students that the teachers were not told that they're going to do any better than anybody else. And these are their gain scores. So what we're curious about is, how do the means of these two groups compare? The experimental compared to the students that were not part of the experiment. And you can kind of see a little bit of what's going on just looking at the chart, right? So here's what I'd like for you to do. I want you to crunch the numbers here. And you can crunch numbers for statistics really easily. That's one of the reasons I wanted to do this today, just to give you a sense of how easy this can be. If you go into, can you jump onto grab your computers or iPads, and the easiest way to get there is through Canvas. So there's a couple of other routes you can take. There is actually a website that's called graphpad.com. And there's an app there, an online app called QuickCalcs T-Test 1. But the easy way to get there is if you go into Canvas, let's see if I can find it here. So in Canvas, under the Modules button, for our class session here, you'll find the PowerPoint I'm using today, the T-Test example in PDF form. That's the handout that you have right now. And then there's actually a link to that calculator. And if you click there, it'll allow you to open it in a separate window. So you can either do that, or you can just type the URL directly into your computer. The quickest way is by clicking on it. And once you get onto that spreadsheet, it allows you to give a label. So for group 1, if you click here, you can put experimental. And if you click on group 2, you can say control. And then there are a series of cells down here. it enters up to 50 rows. You've only got 20 pieces of data, so you're good. We're running what's called an unpaired t-test. It would only be paired if we know who the students are. We're comparing this student pre-test to his or her post-test. We're not doing it by the student, we're just doing a mean. And so you can type in all of the scores for group 1 in the first column and group 2 in the second column. And once you have those numbers in, you can click over here to calculate now, and it will actually crunch the t-test for you and give you a result. So put the data in, have it calculate, take a look at your results and see what it's telling you. Once everybody at your table has crunched the data and you have the results in front of you, would you take a couple minutes at your table to talk about what that data is telling you? What conclusions can you draw?
There's 24 on both sides. I have no idea.
Oh, did you skip a few lines down? Did you start in column 4?
I started in 1. Just, they keep looking through and I cannot
Look at the numbers
find.
on the side, maybe accidentally search.
I'm just like looking. And like they light up and everything.
Unpaired.
What is going on?